Good day everyone, we are the Group 1 and today we will be presenting our topic, Introduction to Computing, Industry in the Profession. We hope you will gain valuable knowledge from our discussion.
The industries that supply computer goods and services are in continual state of change as new product appears and old product are discontinued, as corporation form, merge and die, as corporate leadership shift, as consumer buying habit evolve, and as prices steadily decrease before you venture out to buy computers, peripheral device or software before you commit yourself to a computer career or before you buy stock in computer companies, you should arm yourself with some basic knowledge about the computer and information technology industries. In this module, you will learn about the scope and economics of these dynamic industries. Learning outcome. Differentiate the computer industry from the information technology industry. Identify the different companies included in the IT industry. Discuss and enumerate the different profession and career computing domains, computing discipline and computing knowledge areas. Industry. General definition. Economic activity concerned with the processing of raw materials and manufacture of goods. Professional. General definition. A person would engage or qualify in a profession. Computer industry encompasses those companies that manufacture computers and computer components, include software publisher and peripheral device manufacturers. Information technology industry refers to the companies that develop, produce, sell or support computers, software and computer-related products. Include companies in the computer industry, software publisher, communication service vendors, information service and service companies. Important note, not every company that uses computer in part of the computer industry or IT industry. Banking industry, clothing store, apparel industry. Computer may support a company's operation without making it an IT company. Categories of companies included in the IT industry. Equipment manufacturers design and manufacture computer, hardware, and communication product. Example, IBM, Hewlett-Packard, Cisco, and Blinkist. Chip maker design and manufacture computer chips and circuit boards such as processor, RAM component, system board, sound card, and graphic cards. Example, Intel, AMD, Texas Instrument, Transmeta. Software publisher create computers such as application, operating system, and programming language. Example, Microsoft, Adobe System, Electronic Arts, and Computers Associate. Service companies provide service such as business consulting, website design, web hosting, internet connection, equipment repair, network security, and technical support. Example, AOL and EDS. Computer retailer, also called reseller. These companies sell computer product through retail stores, direct sales representative, mail order catalogs, and website. Important, some IT companies operate in more than one category. Example of multi-sector companies, Dell, Sun Microsoft System, IBM, and Hitachi. Economic factors. Highly dynamic. New technologies, product, and service are constantly being developed. Economic growth. The IT industry creates jobs, support businesses, and contributes to national economies. Global industry. Major computer hardware producing continues include the United States, Japan, Taiwan, Singapore, and China. What make IT industry successful? Demand. More people and businesses depend on computers, software, online services, and digital system. needs. Government and businesses use IT to manage large amount of information and improve efficiency. Competition. Companies use technology to reduce costs, increase productivity, improve services, and remain competitive. Major factors: population growth and businesses globalization.
Marketing channels. Computer retail stores sell computer product directly to customers and often provide advice, support, training, and repairs. Mail order or internet outlets accept order online or by phone and ship product directly, usually at lower prices but with limited support. Value added reseller combines hardware and software to create customized system for a specific business needs. Manufacturer direct. Manufacturers sell product directly to customer without a retail middleman. Manufacturer direct. Manufacturers sell product directly to customer without a retail middleman. Industry self-regulation. Industry organization. Organization provide a forum where the IT industry can discuss important issues, express industry view, develop self-governing policies, establish standard, software and information industry association, protect the intellectual property of its member, support laws and policies beneficial to the IT industry, help identify and fight software and internet piracy.
Industry regulation, export restriction. Some countries restrict what type of technology can be sold to foreign government or individual. Certain hardware and software containing encryption technology may require government registration or approval. Industry concern. Many IT industry leaders oppose excessive government regulation. They believe too much regulation may limit innovation and the development of new technology. IEE Standards Association. IEE helped the IT industry create standards for technologies such as microprocessor architecture, network protocol, programming language, multimedia component. Why are standards important? Standards help different technologies and devices work together reliably and consistently.
We have already discussed the companies and activities included in the IT industry. At this point, let us focus on the people who work within the industry. Our next topic is profession and careers in the computing fields. But before we continue, let me ask everyone, when you hear the words career in computing, what is the first profession that comes to your mind? Is it a programmer, a computer technician, or perhaps a cybersecurity specialist? Well, most people immediately think of programming. However, as we proceed with this topic, we will discover that the computing field offers many career opportunities, not only in programming, but also in management, technical services, operations, training, and security. But first, let us define the term computer professional. A computer professional is a person whose primary occupation involves the design, configuration, analysis, development, modification, testing, or security of computer hardware or software. This means that being a computer professional is not limited to writing computer programs. For example, a computer technician, database administrator, project manager, instructor or professor, or a security specialist may also be considered a computer professional. Now let me ask you, kapag marunong gumamit ng computer ang isang tao, does that automatically make that person a computer professional? The answer is no. A person may simply be a computer user, while a computer professional has a primary occupation involving special responsibilities related to computer hardware or software. Now you may ask, how can we prepare for a career in the computer industry? First, we need to identify the area that interests us and then receive the proper education and training. We may attend a trade school, technical school, vocational school, college, or university. In other words, career preparation begins with self-awareness. Kailangan mo nating malaman kung saan tayo interesado at kung anong skills ang gusto nating i-develop. For example, mas interested ba kayong gumawa ng applications, mag-repair ng computers, mag-manage ng projects, magturo sa users, or mag-protect ng information? Well, that answer to that question may help you identify which computing career area is most appropriate for you. Because an IT department provides opportunities for people with different skills and talents. And these careers are divided into 6 main areas. Let us discuss them one by one. First is we have here management. Management directs the planning, research, development, evaluation, and integration of technology. Sa madaling salita, professionals in this area help determine what technology an organization needs and how that technology will be implemented and how it will support the organization's objectives. In this area, we have these positions. First is the Chief Information Officer or CIO, Chief Technology Officer or CTO, E-commerce Director, Network Administrator or Wireless Network Administrator, and a Project Leader or Manager. The CIO or CTO directs the company's information services and communication functions. An e-commerce director supervises the development and execution of online or e-commerce system. A network administrator installs, configures, and maintains computer networks. Meanwhile, a project leader or manager oversees projects, allocates resources, and organizes the members of the team. Now, imagine that a company plans to introduce a new online system. Who should make sure that the project has a clear plan, the correct people, and the necessary resources? Well, the responsibility may belong to the management area, particularly to a project leader or manager. Now think about this. A company may have advanced technology, but what could happen if no one properly plans or manages its implementation? Well, the technology may not be used effectively. This shows that management is just as important as technical knowledge, because once a technology project has been planned and organized, someone must design and develop the actual system, which this brings us to our second career area. The second career area is system development and programming. This area analyzes, designs, develops, and implements new information technology. It also maintains and improves existing systems. Sa madaling paliwanag, professionals in this area are involved in creating and improving systems, applications, websites, and programs that people use. In this area, we also have different positions. These include computer games designer or programmer, computer scientist, database analyst, desktop or mobile application programmer or developer, and software and web software developer. A computer games designer or programmer turns a game design into an actual computer program. A computer scientist researches, invents, and develops innovative solutions to complex computer problems. A database analyst examines how data should be organized and used. A desktop or mobile application developer converts a system design into a computer program. A web software developer analyzes, designs, implements, and supports web application. So, how many of you use a mobile application before coming to class today? Well, most of us use mobile application every day. But have you ever considered who analyzed the user needs, designed the application, wrote its code, and continued improving it after its release? These responsibilities belong to the professionals working in the system development and programming. Now, what would happen if an application were released without being properly analyzed, developed, and tested? Well, it could contain errors, fail to meet the user needs, or become difficult to use. That is why this area involves more than simply writing code. However, after a system has been developed, it must still be installed, maintained, tested, and supported. These responsibilities lead us to the third part, which is the technical services. Technical services evaluates and integrates new technologies, administers the organization's data resources, and supports the centralized computer operating system and servers. In simpler terms, professionals in this area make sure that the organization technology remains functional, properly configured, updated, and reliable. Here we have several job titles. We have computer technician, database administrator, desktop publisher or compositor, digital forensic examiner, graphic designer or illustrator, quality assurance specialist, storage administrator or analyst, web designer, and webmaster or web administrator. A computer technician installs, maintains, and repairs hardware and also installs, upgrades, and configures software. A database administrator creates and maintains the data dictionary and monitors database performance. A desktop publisher or compositor formats and combines text and graphics to produce publication-ready materials. A digital forensics examiner collects and analyzes evidence found on computer and networks. A graphic designer or illustrator develops visual materials for advertisements and marketing. A quality assurance specialist reviews programs and documentation to ensure they meet the organization's standards. The storage administrator installs, maintains, and upgrades storage systems and analyzes storage needs. A web designer develops graphical web content, meanwhile a webmaster or web administrator maintains the organization's website and monitors its performance. Suppose your computer suddenly stops working 1 hour before an important presentation. Who would you immediately look for? That would be a computer technician. But let us consider another situation. What if the hardware is functioning correctly, but the organization database is slow, disorganized, or inaccessible? Would the computer technician alone be enough? Not necessarily. The organizations may need a database administrator or another technical service specialist. However, computer equipment, networks, backups, and communication systems must also be monitored during daily operations. This brings us to the fourth part, which is operations. Operations separates the centralized computer equipment and administers the network, including both data and voice communication. Professionals make sure that computer equipment, communication systems, and network connections continue to operate properly during the organization's daily activities. Here we only have two job titles. We have the computer operator and data communication analyst or BOIP specialist. A computer operator performs equipment-related activities such as monitoring system performance, running scheduled jobs, creating backups, and restoring data. A data communication analyst or BOIP specialist installs and monitors communication equipment and software and maintains internet or wide area network connections. Let me ask you, have you ever experienced losing an important file because you did not create a backup? Now imagine that happening to an entire organization instead of only one person. What would be the possible effect if the organizations had no proper backup and restoration process? The organizations could lose important information and experience interruption in its operations. This is why monitoring, backup, restoration, and network maintenance are essential responsibilities. Even when a system is complete and functioning, employees must still understand how to use it. This brings us to the fifth area, which is training. Training professionals teach employees how to use components of the information system and answer specific questions from users. We have the IT, IS, or CS instructors, corporate trainer, and help desk specialists. An IT, IS, or CS instructor teaches students computer science and information technology skills. A corporate trainer teaches employees how to use software, design and develop system programs, and perform other computer-related activities. A help desk specialist answers computer-related questions in person, over the telephone, or through online communication. Now let me ask you, is advanced technology useful if the employees do not understand how to operate it correctly? Well, its usefulness will be limited. Technology becomes more effective when users receive proper guidance and training. Have you ever helped a classmate or family member understand how to use an application or solve a computer related problem? In a simple way, you were already performing a task related to training or user support. After users learn how to operate a system, another major responsibility remains: protecting the system and its information. This brings us to our sixth and final career area. The sixth and final career area is security. Security professionals develop and enforce policies designed to safeguard an organization's data and information from unauthorized users. In this area, we have different positions. We have the Chief Security Officer or CSO, Computer Security Specialist or Mobile Security Specialist, Network Security Administrator, and Security Administrator. The Chief Security Officer is responsible for physical security of the organization's property and people, and is also in charge of securing computing resources. A computer or mobile security specialist is responsible for protecting data and information stored on computers and mobile devices. A network security administrator configures routers and firewalls and specific web protocols and enterprise technologies. A security administrator manages network security access and protects the organization against unauthorized access. Suppose you receive a message containing an unfamiliar link and asking for your password. Would you open the link immediately or would you verify the message first? Well, that simple situation already involves security awareness. Now imagine that information being targeted is not only one password, but the personal information of thousands of customers. What could happen to an organization if unauthorized users gain access to that information? It could result in information loss, unauthorized use of data, and serious damage to the organization. This is why security professionals and security policies are essential. Now, let us reflect on one final question. Among these six career areas, which one best matches your interests and abilities? And what skills would you need to develop to become qualified for it? The lesson shows us that computing career is not limited to programming. The field needs people with different strengths, people who can lead, analyze, create, repair, and operate, communicate, teach, and protect. Now that we have identified the profession and careers available in the computing field, let us proceed to the next part of the lesson, the 10 domains in computer science.
Computer theory is the study of how computers solve problems. Now, it has three main areas. Number one, computability theory. Tell us if a problem can be solved by a computer. Number two, complexity theory tells us how much time an algorithm needs to solve a problem. Number three, formal language studies the rules and structure of computer language. The next is algorithms are step-by-step methods used to solve a problem. Computability theory focuses on finding out whether a problem can be solved by a computer using a finite number of steps. Cryptography is a method used to protect information from unauthorized people. It changes data into a secret form so that only the intended person can read it. Distributed computing means using several computers to work together on one problem. Instead of one computer doing everything, the work is divided among different computers. Each computer handles a part of the task and the result are combined. Cloud computing means using the internet to access and store files, applications, and data instead of keeping them only on your own device. For example, Google Drive lets you sort files online and access them for different devices. Computational learning, also known as a machine learning, allows computers to learn from data and improve their performance. For example, YouTube recommends video based on the videos you watch and search for. The computer learns your preference and uses that information to suggest similar content. Computer vision is a technology that allows computers to analyze and understand pictures and videos. It can be used for things like recognize objects, detecting movement, and helping robots navigate. Big data is a large amount of information collected from different sources such as social media, website, and online transactions. It is analyzed to find patterns, trends, and used for information. Neural networks are a type of artificial intelligence that is inspired by how the human brain works. They process information from data and learn to recognize patterns. For example, they can be used for face recognition, image processing, and making prediction. And the lastly is intractable versus intractable problems. A tractable problems is a problem that a computer can solve in a reasonable amount of time. Even with several possibilities, it can still be solved efficiently. On the other hand, an intractable problem is much harder to solve because it may take an extremely long time, especially when there are too many possibilities.
Good day, everyone. For my part, I will be discussing the different computing disciplines and majors. Computing is a very broad field, which is why it is divided into different disciplines. Each discipline has its own specialization and prepares students for different careers in the technology industry. Let's begin with computer engineering. Computer engineering focuses on both hardware and software. Students learn how computers and digital devices are designed and how hardware and software work together. They also develop embedded systems, which are computers built into devices such as smartphones, vehicles, home appliances, and medical equipment. In simple terms, computer engineers build and improve the technology that powers modern devices. Next is computer science. This discipline focuses on programming, problem solving, and developing new computing technologies. Computer scientists create software, design algorithms, improve cybersecurity, and explore areas like artificial intelligence, robotics, and computer vision. Their goal is not just to write code, but also to develop innovative solutions to complex problems. Now, let's move on to information systems. Information systems combines technology with business. It focuses on how organizations can use information and technology to improve their operations, make better decisions, and increase productivity. This discipline is ideal for those who enjoy both technology and business management. The next discipline is information technology. Information technology is more focused on the practical use of technology. Information technology professionals install, maintain, troubleshoot, and secure computer systems and networks. They also provide technical support and ensure that an organization's technology runs smoothly. Simply put, they keep computer systems reliable and efficient. Lastly, we have software engineering. Software engineering focuses on building large and reliable software systems. Unlike regular programming, software engineers follow structured processes to make sure software is secure, efficient, easy to maintain, and meets the needs of users. Examples include banking systems, online shopping platforms, healthcare systems, and other large scale applications. To conclude, each computing discipline has a unique focus and career path. Whether your interest is in hardware, software, business solutions, technical support, or software development, there is a computing discipline that matches your skills and interests. Understanding these disciplines can help students choose the right career path and prepare for the rapidly growing technology industry. Thank you, everyone. That concludes my presentation.
Now, let's move to mixed disciplinary majors. Bioinformatics. Bioinformatics is a course that combines different subjects like biology, biochemistry, and computer science. It teaches students how to use computers and technology to study biological data such as DNA and genes. This course prepares students for careers in biotechnology, pharmaceutical companies, research, and healthcare. Some schools also include mathematics, statistics, chemistry, and information systems because these subjects help in analyzing and managing biological information. Computer science and mathematics is a program that mixes both computer science and math. You'll find this program in two kinds of schools. First, in schools that don't have a full computer science degree, so they combine it with math to give students tech skills. Second, in big universities that do have a full computer science department where they offer this as a specialized program. Gaming and animation programs are designed for students interested in developing computer games and animations. These programs are being offered by more schools today and they vary in focus. Some combine technical areas like computer science and information technology with creative areas like art and digital media studies. This allows students to gain both the technical skills to build games and the artistic skills to design them. Medical or health informatics is for students who want to work in the medical field, but with a focus on technology. Graduates can work in different places. Some become technology experts in hospitals, other works in public health, and some use it as a path for pre-med or pre-dental. The coursework is a mix too. It combines computer science, information systems, or IT with biology, chemistry, and other courses specific to health. So basically, it's where healthcare meets technology.